students, how are you doing? I hope you are doing well. In the previous class, we revised chapter 3 that talks about linear equation and inequality. In the case of linear equation and inequality, we discussed also a Cartesian coordinate system. And you were having 5 exercises. I hope you tried. Good. Today, we will discuss on chapter 4 or unit 4 that talks about similar figures. In the case of similar figures, first let's define any kinds of similar plane figures. In the case of a geometric figure having the same shape, the first thing, the same if a figure have the same shape and having equal corresponding angles, and the last one having corresponding sides have to be proportional. If the 3 cases are satisfied, we can say the 2 figures or the 3 figures are similar figures. As I told you before, the first thing is they have to be the same shape. If they are not the same shape, we cannot compare it at all. We do not go to the second and the third step. After they have the same shape, we go to the corresponding angles have to be the same. The third one, their corresponding sides have to be proportional. So, after talking about the similar figure, let's go to the next illustration and definition of similar figure. This is the formal definition of similar figure. In the formal definition of similar figure, 2 polygons are similar if and only if they have to satisfy. The first thing is their corresponding sides have to be proportional. Therefore, the first step, they have to be proportional. Corresponding sides will be proportional. The second one, their corresponding angles are congruent. Congruent means, in other words, it means equal. Therefore, if 2 polygons have their corresponding sides are proportional and corresponding angles are congruent or equal, then we can say the 2 polygons are similar. So, to check this, first let's see a central enlargement. In the case of central enlargement, it says which is either increasing or decreasing with the same ratio. That means this without changing their shape. If the shape is changed, it's not the same or it's not similar. So, in the case of central enlargement, either increasing or decreasing of the size of the figure without affecting their shape. So, under an enlargement, there are 3 cases. The first one, their lines and their image are parallel. Image and lines are always parallel. That means they do not intersect each other. The second one, angles remain the same. Angles will not be changed. It's always congruent or equal or the same. The last one, all lengths are increasing or decreasing in the same ratio. That means the sides are either increasing or decreasing with the same ratio. So, let's see this figure. In this figure, let's see, this one is the object figure. The object figure means this one is the original figure. Therefore, this is the center, that is called central enlargement. Then the image figure, after enlarging this image, we have this, the biggest image. Therefore, this is image figure. Therefore, always lines are always parallel. And the angle that makes here and here is always the same. That means angle will not be changed at all. And this side and these sides are increasing with the same ratio. That means because this line and this line is proportional. If it is proportional, either increasing or decreasing. If it is increasing, if the object figure is changed to the image figure is greater than the object figure, at this time, this kind of figure or enlargement is called a positive enlargement. So, let's go to the next concept, the scale factor and proportionality. A scale factor means, as we defined before, the sides are either increasing or decreasing with the same ratio. That ratio is called the scale factor. The formal definition of this scale factor is the ratio of corresponding sides, usually expressed as like this. The scale factor is equal to length of line segment of the enlargement over the original. Simply, the length of the line segment of the enlargement means that is image figure. And this one is the object figure. Therefore, the scale factor is equal to image figure over object figure. Therefore, the notation of this scale factor is denoted by K. That is capital K. Therefore, the notation of the scale factor is K. Therefore, K is equal to image figure over object figure. This is the formal definition and formula of the scale factor. So, this K have different values. If the value of K is greater than 1, that means it may be 2, 3, 4, 5, that is greater than 1. If the value of K is greater than 1, then the image figure is always greater than the object figure. That means the image figure is the enlargement is always increasing or positive enlargement. The second one, if the value of K is between 0 and 1. If the enlargement is between 0 and 1, the image figure is smaller than the object figure. That means the image figure is smaller than the original figure. That means the value of K is between 0 and 1 means it is a fractional number. The last one, if the value of K is equal to 1. In this case, there is no an enlargement at all. That means the image figure and the object figure is always the same. For instance, if you see yourself on the mirror, there is no increasing or enlarging image. It's always the same. Therefore, the value of K is always equal to 1. That means there is no an enlargement at all. Image figure and object figure is always the same. But in the case of K is between 0 and 1, it calls that it's negative enlargement. In the case of negative enlargement, K will not be negative value, but it is the image figure is smaller than the object figure. It means the value of K cannot be negative. So, the next is similar triangle. Let's specify it. From the similarity of figures, let's take one figure or let's one thing that is triangle. So, when we talk about the triangle, it's a three-sided polygon is called a triangle. So, to say these two triangles are the same, we have a formal definition. The formal definition, it says triangle ABC is similar to triangle DEF. That means triangle ABC is triangle DEF. To say these two are similar, they have to satisfy two things. The first one, their corresponding sides are proportional. That means this side have to be proportional to this side. This side will be proportional to this side, and side BC is proportional to side EF. The second thing, their corresponding angles are congruent. That means angle A have to be congruent or equal to angle D. And also angle B have to be congruent to angle E. And also angle C is congruent to angle F. If these two things have to be satisfied, then we can say the two triangles are similar. Let's define it. Here, symbolically, angle A have to be congruent to angle D, angle B congruent to angle E, angle C have to be congruent angle F. These three are called corresponding angles are congruent. The last one, their proportionality means AB over DE is equal to BC over EF. BC over EF, that means this side over this side, have to be equal to AC over DF. AC over DF. These three ratios have to be equal. That means this ratio is called the scale factor K. If these three ratios are equal, then we can say it is their corresponding sides are proportional. Now, let's see one example. The example, it says, let triangle ABC is similar to triangle DF. Then, as shown in the figure below, then from this figure, triangle ABC and triangle DEF are similar figure. Then find the measure of angle F. What is the measure of this angle? And what is the measure of angle E? Angle E. What is the measure of this angle? And the last one is the length of BC. That means this value of A. So, before I'm going to do this example, try it for 1 minute. Very good, students. Hope you tried good. So, let's do it together. The solution says, in the figure, triangle ABC and triangle DEF are similar. If they are similar, their corresponding angles are similar and their corresponding angles are congruent and their corresponding sides are proportional. That means this angle is congruent to this angle. That means it is 30 degree and 30 degree. And also angle C is congruent to angle F. That means if the value of C is 100 degree, the value of F is also have to be 100 degree. And the last one is this angle have to be congruent to this angle because the two triangles are similar. And also this side is proportional to this side and this side is proportional to this side and this side have to be proportional to this side because the two triangles are similar. So let's come to the solution. The given it says the two triangles are similar. Then angle A and angle D are equal because they are both of 30 degree, equal angle measurement. That's a given value. The next one is angle C and angle F are congruent because the two triangles are similar. Therefore, if the value of angle C is 100 degree, the value of angle F is also 100 degree. Therefore, angle F is 100 degree. The next one, measure of angle A plus measure of angle B plus measure of angle C. As you know it before, the sum of interior angles of the triangle is 180 degree. Therefore, angle A plus angle C plus angle B is 180 degree. So the value of angle A is 30 degree. The value of angle B, we don't know the value of measure of angle B, and measure of angle C is 100 degree. So let's substitute. Angle A is 30 degree, angle C is 100 degree. Now let's add it 2. So angle B is equal to 180 minus 130. This 130 means 100 plus 30, that is 130. So 180 degree minus 130 degree, it is 50 degree. That means the measure of angle B is equal to 50 degree. So therefore the measure of angle E is also 50 degree. Because these two triangles are similar, therefore angle B and angle E are congruent. Therefore if the angle B is 50 degree, then angle E is also 50 degree. So let's come to the last one, C. In the case of C, these sides have to be always proportional. If the two triangles are similar, their sides is proportional. Therefore, AC, AB over DE, that means AB over DE, have to be equal to BC over EF, have to be equal to AC over DF. This is called a scale factor K. Now, let's substitute the value of AB, DE, BC, EF, and AC, DE. So, what is the value of AB? AB is 16. So, the value of AB is 16 over what's the value of DE? That is 12 is equal to BC is A. We substitute in place of BC is A over in place of EF, the value of EF, it is 5. Now, let us crisscross it. Now, A times 12, 12A is equal to 5 times 16 is equal to 80. So, let us divide both sides by 12. When you divide it by both sides by 12, it is A is equal to 80 over 12. 80 over 12 is equal to, therefore, the length of BC is equal to 80 over 12. Therefore, this side is equal to 80 over 12. Okay, this is the solution of the example. So, let's go to the next concept, that is test of similarity of triangle. Before we are going to discuss about the test of similarity of triangle, in the case of the definition of similarity of triangle, they have to satisfy 6 things. That means for the case of two triangles, we have to check 6 things. The first one, this angle have to be congruent this angle. 1, this angle have to be congruent this one. 2, this angle have to be congruent to this angle. We have to check 3 angles have to be congruent. Therefore, we do 3 things here. The next one, we check proportionality. In the case of checking proportionality, this side have to be proportional this side. 1, this side proportional to this side. 2, this side have to be proportional to this side. Then here is also we check 3 things. Totally, we check 6 things. So it's a little bit boring to check this of all possibilities. So to minimize this, we use these 3 theorems. That is side, 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 side angle, side, and angle, angle similarity. Let's first discuss about angle, angle similarity theorem. In the case of angle, angle similarity theorem, it says if 2 angles of one triangle are congruent to the corresponding 2 angles of the other triangle. So we have 2 angles of the first triangle is congruent to the second 2 angles of the second triangle, then we can say simply the 2 triangles are similar without checking their proportionality. Let's see it. As an example, here is two triangles. The first triangle is WRS and VSB. So these two triangles are they the same or are they similar? Using simply this theorem. If you want to check, you can use using the definition, you have to check 6 things. But simply using theorem 4.1, that is angle similarity, it says, let's say, angle R and angle V are equal because their angle measurement is already given, that is 45 degrees, because angle R is congruent to angle V because their angle measurement is 45 degrees. The second one, angle RSW, this angle, and this angle is always equal because they are vertical opposite angle. In Amharic, jerba angle. That is called vertical opposite angles. Therefore, we have two angles are congruent. Therefore, from the theorem it says, if two angles of the first triangle is congruent to two angles of the second triangle, then we can say simply the two triangles are similar by angle similarity theorem. So simply by checking only two angles, we can say the two triangles are similar because of angle similarity theorem. Okay, students, the next theorem 4.2, it says side angle side similarity theorem. In this theorem, it says if two sides of first triangle is proportional to two sides of the second triangle and their included angle is congruent, then we can say the two triangles are similar. Students, attention here. Two sides of the first triangle is proportional to second triangle and their included angle is congruent, then we can say the two triangles are similar simply by theorem of side angle side similarity theorem. To solve this, let's see an example. In this example, we have two different triangles, that is ABC, triangle ABC and triangle DEB. So these two triangles are they the same or not? So check this, we can use side angle side similarity theorem. Before using this side angle side similarity theorem, let's use angle similarity theorem. To solve this, we have to check two angles have to be congruent. So we have this angle is congruent to this angle because they are vertical opposite angle. Do you have another angle here which is congruent to each other? No. Therefore, we don't use angle similarity theorem. So let's come to side angle side. In the case of side angle side similarity, we check only one angle and two sides. So let's check it. So angle ABC, that means ABC, this angle and this angle is equal because they are vertical opposite angle, and AB over EB, AB over EB, this side and this side have to be equal to 2 over 3, that means 12 over 18, that is 2 over 3, and this side and this side, that means BC over DE, BC over DB. Therefore, 16 over 24, that is 2 over 3, because then this side and this side are proportional, this side and this side is proportional. From the definition, it says two sides are proportional and their included angle, this is the included angle, and also this side, this included angle is also congruent, then we can say these two triangles are similar by what? By side angle side similarity theorem. Let's see the last theorem. It said side-side-side similarity theorem. In the case of side-side-side similarity theorem, it says the three sides of the first triangle have to be proportional to the three sides of the second triangle. So without checking their angle, simply by checking the proportionality of their sides, we can say the two triangles are similar. Let's see an example of this. The example, let's say these two triangles are similar or not. To check this, we can use different theorem. The first theorem, it says angle similarity. There is no angle that's given. The second theorem is also side angle side. It's also asking an angle. Here is there is no given angle here. Therefore, the only possibility you can use side-side similarity theorem. In the case of side-side similarity theorem, let's check their proportionality. That means AC over EF have to be equal to BC over DE and AB over FD. That is AC over EFE means AC over FE means 8 over 16, which is 1 over 2. And CB over ED, that is 10 over 20. There is 0 cancelled by 0, that is 1 over 2. And the last one, AB over FD, that means 14 over 28 by 14 1 by 14 2, that's 1 over 2. Therefore, this AC over FE is equal to CB over ED is equal to AB over FD is equal to 1 over 2. Therefore, these three sides are proportional. So, using the theorem of side-side-side similarity theorem, we can say the two triangle ABC is similar to triangle FDE are similar by what? By side-side-side similarity theorem. So, the next concept is perimeter and area of similar triangle. In the case of perimeter and area of similar triangle, it is theorem 4.4. It says the ratio of their corresponding sides of two similar polygons is K. That means the ratio of their sides is called their proportionality ratio. That's called scale factor. The scale factor is denoted by K. Therefore, S1 over S2 is K. Now, let me draw two triangles here. Triangle A, B, C, D, E, F. Now, if you have two triangles, let's say this side is S1, this side is S2. Therefore, the scale factor K is equal to S1 over S2. Now, the ratio of their sides is equal to the ratio of their perimeter. Perimeter means the sum of their sides. That means the sum of these three sides is called, let's say, perimeter 1, and for this one, perimeter 2. Therefore, if you take the ratio of their sides is equal to the ratio of their perimeter. That means this is S1 over S2 is equal to P1 over P2. Therefore, the theorem states that the ratio of their sides is equal to the ratio of their perimeter. That is called a scale factor K. The next theorem, it says, theorem 4.5, it says, if the ratio of their corresponding sides of the two similar triangle or polygon is S1 over S2 is equal to K, then the ratio of their area is given by A1 over A2. As I said before, there is two triangles, let's say A1 and A2, equal to the square of their sides, that is S1 over S2 the whole square, or simply you can square it the scale factor. So let's see an example. This example, it says find the ratio of the area of two similar triangles. In the case of solving this, finding the area of similar triangle, if the ratio of their corresponding side is 4 over 5. At this time, you are given S1 over S2 is equal to 4 over 5. And the second one, if the ratio of their perimeter is 9 over 10. That means the given is P1 over P2. So let's come to the solution. In the case of A, A1 over A2 is equal to S1 over S2 the whole square. That means from theorem 4.5. Now let's substitute the value of S1 over S2. In the case of substituting S1 over S2, A1 over A2 is equal to 5 over 4 the whole square. So 5 square is 25, 4 square is 16. Therefore, A1 over A2 is equal to 25 over 16. B, A1 over A2 is equal to S1 over S2. This S1 over S2 is equal to P1 over P2. That is from theorem 4.4. Simply, let's substitute in place of P1 over P2. That is A1 over A2 is equal to 10 over 9. 10 over 9 squared is equal to A1 over A2 is equal to 100 over 81. Let's see the last example and let's conclude the chapter. The area of two similar polygons are 80 cm square and 5 cm square. If the sides of the smaller polygon is 2 cm, find the corresponding sides of the larger polygon. That is, let's say A1 and A2 is the area of the polygon and S1 and S2 are their corresponding sides. So A1 over A2 is equal to S1 over S2, the whole square. So A1, in place of A1, S1 over S2 the whole square, in place of A1, 80, the value of A2 is equal to 5. And the value of S2 is equal to 2. Now, S1 square over 2 square. 2 square is 4. 80 over 5 is equal to 16. Here is over 1, then crisscross it. That means S1 square is equal to 4 times 16, that is 64. Therefore, S1 is equal to the square root of 64, that is 8 centimeter. So, this is all about Unit 4. If you have any question, you can use Afriel's TV or you can text using 8455. If you need to use the social media, you can check it Similarity Babeti. After this, you will have an exercise. Try it at home. Until the next class, bye-bye. See you.